Here's the story. Earlier this week, a Google engineer or ex-Google engineer posted his conversation with Google's AI chatbot, LaMDA, and claimed that the conversation technology is sentient. And it is already capable of expressing its feelings and thoughts like a human child. This is a quote from the Washington Post. If I didn't know exactly what it was, I would think it was a 7-year-old or 8-year-old kid that happens to know physics. As far as I'm aware, LaMDA, which in full is Language Model for Dialogue Applications, is Google's system for building chatbots which can process and learn from Google's billions of data sets to generate conversational context like we humans do. Today, I'm super excited to have this conversation with Victor. To get a small warm-up, let's start from a more fundamental questions. Victor, what is AI? If you were to explain it to, let's say, 10-year-old kid, how would you explain it?
So in my view, or my definition of the word, or when I were to explain it, I would say it's a system built to be able someone or something to teach it to perform a task.
Right.
So maybe a system where you teach it to find all soccer balls in an image or recognize this person's voice or a task like that.
Okay, so I guess the key word is you have to teach it to perform a certain task. That's the two main thing in an AI system, right?
Yeah, that's what I would say that, yeah. That's
okay.
what I think.
And have you heard about the tech giant's story?
Yeah.
I guess it's a big news in tech AI industry,
yeah,
right?
It's pretty funny. Yeah, I read some of the news articles, and most importantly, I also read the paper.
And can you share a little bit with us?
Yeah. So LaMDA is quite interesting because they've added a lot of things on top of a decoder model. So when it comes to predicting the next token, they do more things with that, and that's very interesting, and that makes it more competent.
Okay, I have two questions. So you mentioned something about decoder and tokens. Can you further elaborate those two?
Yeah, so when you have a text and you want to split that text into words, it's not really possible because there are so many words, so that file would become huge. So there's very clever ways of compressing texts and words into subwords that are more easily handled by the computer. Mm-hmm. And one of those part of a word is a token. So play could be playing, place, and many various adaptations or variations of the same word. So play might be a token, and ing might be another token.
If I understand it correctly, the conversational system is kind of to examine the relationship between different tokens and create or predict the subsequent words or tokens after the current ones.
Yeah.
Am I right?
Yeah, that's what a decoder does, or an autoregressive language model. That's like their task. Like, what's the probability of this next token, or yeah, so that's like basically what it outputs, probability of the next token given a previous text.
So let's go back to Blake's story. So I guess the most controversial part is he claimed that the AI system is sentient. Do you think that the system is actually as sentient as he claims or he thinks?
No, I do not. Like in general, since we're talking about it, the only thing these type of models do is they're trying to predict the next token. That's like their task. That's their utility function. That's like what they are designed to do, predict the next token. So when you have trained it, it's done. It doesn't update, it doesn't change, it doesn't learn anything else. So when you're having a conversation with it, it doesn't remember it, and the next time you're talking to it. So it's just a set of weights, model weights. So it's just a list of numbers within a list within a list within a list. So it's nothing there quite yet. But it's very interesting that it's getting that difficult, or it's getting that good to mimic what a conversation feels like, and even the experience kind of thing, since he's going this far.
Okay, so if I applied it to our daily use cases, when I type on my phone and then the system kind of suggests me the next word. So for example, if I say go, and then the next word will be to, basically, right? So is it some kind of similar mechanisms?
Yeah, that's a really good explanation. That's like what these systems are, basically. It's autocorrect on steroids. So that's a good way of thinking about it. So it's difficult to become sentient on autocorrect.
Okay, so I am especially interested in the functions, like how LaMDA system work. Can you give us brief or detailed introduction?
So what LaMDA does is not only predicting the next token, they have also added other tasks. So it's not just like, given this text, what's the next most probable word? It's instead like, what type of task do I have to perform to generate the most probable word?
Mm-hmm.
So it's like, maybe I have to search and look up this person if someone asks about the age, or ask something about a book. Maybe it has to look up and look at the review or something about the book in order to be able to make a good answer. So not only predicting the next token, but also like predicting the next function or the next step to be able to produce the best token. So it's a very nice and interesting add-on to this. And doing that like within a context of like GPT-3, who's another huge model, but that's just a decoder model, so it doesn't do anything else than, given all the text that I have seen previously, this is the most probable token. So whereas LaMDA is more like, what tasks do I also have to perform in order to answer this question?
I spontaneously think of Siri. Like when you ask Siri some questions and Siri give you answers. Is that kind of similar?
No, I don't think so. I would say that Siri is more similar to our platform. So you have like intent classification, mainly called with chatbots, like what are the intent with this command that the user is saying.
Right.
So then they classify that, and then they have like some clever script that answers that.
Okay.
So this is like more, now when you're interacting with the GPT-3 or LaMDA, you're actually interacting directly with the neural network.
Okay, I guess that's pretty clear on what's going on, what's LaMDA, and what's the controversial part of the story. And let's move on to the future. I was wondering, do you think that AI models will be as sentient as we expected in the near future?
It's difficult because like when something becomes sentient, I'm pretty sure we'll have like a similar news story to what we're discussing right now. It will look like this: someone's sounding the alarm and then they're seeing something that they think. But when that will happen is very difficult to predict. Like it's like the growth of compute and the performance and the main usage you can do is like it's so fast, it's difficult to comprehend what will happen. And also the progress within the deep learning community, it's a lot of research going on, so I can't say, but yeah, I still think it's possible within a lifetime.
From your speech, I heard something about people get nervous or scared about the advancement of the algorithms or the AI development, right? What's your opinion on that?
Yeah, so it's going very fast. It's difficult to keep up with, but in general now we're seeing like we're adding more functions on top of previous architectures and adding, like trying to make older architectures more effective and less compute heavy. And like 2 or 3 generations down the line when it comes to architectures. I think that's when it might become a bit scary in general. But like we're not in the world of AGI, which you see in movies and TV shows. Like these are very specific systems designed to do very specific tasks. So like LaMDA it's basically designed to perform the task of doing a dialogue or a chat. And by mimicking that or trying to perform that task, it's having to emulate like some part of the real world or a real interaction in order to make it feel like a real interaction. But it's still far away, and you should not be scared by this mimicking that's going on.
Can we say that the system will kind of develop the cognitive self-awareness or kind of its own patterns or personality or habits to respond to some questions?
So that's a really heavy question with various parts. Like in general, like going sentient, there's a lot of things required for that. And what you said in part 2, I think it's like the main thing is like what's their function, the loss, like what is the model trying to optimize.
Right.
So right now it's trying to optimize like the probability of that the next token is the correct one. That's like its only purpose. That's the only thing it's trying to do right now. So you have to like put the whole world into tokens and turn them into tokens. So it turns into a token problem. And then you also need like it needs to adapt and update in real time. So like the tasks, what would the next token be like? What would the token be? Couldn't be just subwords. It would have to be like some sort of state of the current world that it's in, and then like predicting the next, and then like doing some sort of action. That's difficult, or that's quite far off, I think. But then like when it comes to the personality part, that's quite interesting. So that could happen in various ways, I think. Like in general, what is a personality now? My guess is that it depends on like your cultural upbringing, and also like who your parents are and what your friends were and what area you grew up in, and also how your genetics then is being affected by that environment. So like when you're a kid and you say something rude in the schoolyard, you get direct feedback, and you try to maximize your utility to function so you can get and play with the other kids, so you don't become rude basically by that sort of function. But since computers are in this type of world, they're basically getting data from the internet, so they're in the same environment, all of these models. But it might be that models trained on only specific languages might adapt like some specific traits that are in a general way applicable to that type of culture that also uses that language.
I get it.
But when it comes to LaMDA and everything, they have a very interesting part of their training process where they select. I think it was four types of criteria that they have for selecting the best answer. So these models can generate 50 different answers to the same question or to the same set of historical dialogue. So you can then sample from those 50 different outputs by like, so one thing that LaMDA is doing is how interesting is this? So like if this token or if this text has a high probability of being interesting, that gets favored by the output selecting algorithm. So that in a way creates an engaging conversation or a personality where it's trying to emulate an interesting person.
That's all from us today. If you're interested in AI and its applications, please feel free to check labelf.ai. I will also put a link in the description. I'm Anthony. See you all next time. Bye bye.